So the first component that we're going to put in is the push button. So let's do that now. Now you'll note that there's two orientations that the push button can have, one of which it will fit in and the other one it won't. So you need to make sure that the legs that splay outwards go into the rows. So once you push it down, you should find that the leads fit comfortably into the rows here. If they don't, try turning it 90 degrees and trying again. So at this stage they're in row 5 and row 7. Now the way that this push button works is that this side of the push button and this side of the push button when the button is not pressed are not connected, and then when you press the button the two sides become connected. So our next component that we want to use is our resistor, and it is brown, black, orange and gold in the stripes. So let's turn that into a U shape again like we did before, and then connect it to this lower right hand lead of the push button like so. So you can see now that this leg of the push button is connected to the resistor. Again, it doesn't matter which way around the resistor goes, and then through to here I've got it into row 13. Now let's look at the power. So again, like before in our first example with the LED, we're going to have one red for 5 volt power and one black for the 0 volts or ground connection. So let's make that connection now into any of the ground or GND spots, and then into the blue negative line. So we've got our connection from ground through the black jumper and into this row on the power rail. Then we want to connect the 5 volts, and this time we will be using 5 volts, so we need to connect it. So push that into 5 volts there, and you'll notice there's only one place that you can connect it that's 5 volts, so make sure you put it in 5 volts and not in the 3.3 volts. And then connect the other end into the positive 5 volt rail on here. So this means you've got a connection from 5 volts going through your red jumper lead onto the 5 volt power rail. So next we want to connect the ground to the resistor, and so this means that we will have our pull, make the resistor work as a pull down. So grab another black jumper wire for that and connect from the ground rail to row 13, which is where our lead is. So this means we've got a connection running from ground up through the black jumper, along the power rail, and then up through the second black jumper into row 13, and then into the leg of the resistor, along the resistor, and then into row 7, and then into the push button. So at this stage we have we stop our circuit here. So what we need to do now is, if you refer back to the diagram, you can see that we need to have a connection from that side of the push button into the pin on our Arduino, which in this case is pin 2. So we'll get another cable, a jumper, and again, like we used with the LED, because this is going to be carrying a signal, we want to use something other than red or black. So we're going to use an orange jumper. So let's plug that into row 7 on the other side, so that's 7J, and then plug it into pin 2. Now we can trace our circuit at this stage. So this is at the moment the button is not pressed, and so this is the circuit which is formed. So it goes from ground up through the black jumper cable, along the power rail, up through this jumper and into row 13, then along row 13 into the resistor, through the resistor, down the other side into row 7, along row 7 into the push button, through this side of the push button, and then carrying on to row 7 on the other side, and then over the orange jumper into pin 2. So this means that when the button is not pressed, the value that we get when we sense the value will be 0 because that is ground. So it's the low or ground value. So tracing that again, we can come back the other way to check that, that we've followed this correctly. So pin 2 is going to have its input from along the orange wire, along row 7, through this side of the push button, and then through the resistor, along the black jumper, and along the power rail through the second black jumper into ground. So now we know that when we don't have the button pressed, then we're going to have a low reading on our pin 2. So now we want to have it so that when we do press our button, that we're going to get a connection to 5 volts. So this time we can take our red cable and plug it into the 5 volts, and then plug that into the other leg of the push button. So now we can trace our signal input for pin 2 from 5 volts along the red power cable, then along the 5 volt power line, then along this jumper into row 5, which carries along row 5 and into this leg of the push button. And then when we press the push button, we know that we're going to get a connection from this side across to this side, and so we can then follow that signal along row 7 and then through the orange jumper into pin 2. So again, when we trace the signal back, the button is pressed, pin 2 along into row 7, across because the button is pressed, into row 5, and then along row 5, along the red jumper, along the red power rail, and into 5 volts. So we've now handled both states of the push button. When it is pressed, then we know we're going to get a 5 volt or high reading, and then when it's unpressed, we're going to get a 0 volts or low reading. So let's have a look at the code now in the example sketch on how to actually read these values.